discuss graphs, functions, and equations. In Module 7, Section 1, our focus will be a review of equations of lines and writing parallel and perpendicular lines. Again, let's review a few forms of lines that we saw in previous modules. First, we have the slope-intercept form, which uses specifically the y-intercept in the equation. The slope-intercept form of an equation is y equals mx plus b, where the m represented the slope and b represented the y-intercept. The form allows you to use any point together with the slope to form the equation of a line. Here we see the point-slope form given. Y minus y1 equals m times the quantity x minus x1, where m is the slope and x1, y1 is any point on the line. Find an equation of a line with the slope -2 through the point -11, -12. Write the equation in standard form. This is the third form of lines that we've seen before, and the standard form is ax plus by equals c. Essentially, this means we want x and y on the left-hand side of the equation and our constant to be on the right-hand side. But regardless of the ending form, we're always going to start by labeling our information and plugging it into the point-slope form. So first we are given a slope -2, and the slope is always represented with the letter m. Then we're given a point, and since we have one point, we label it x1, y1. Now that we have the appropriate information labeled, let's write down our point-slope form. Y minus y1 equals m times x minus x1. Once we have that written, we're going to plug in for m, x1, and y1. That will give us y minus -12 equals -2 times x minus -11. Now remember, anytime we subtract a negative, that's the same thing as adding a positive number, so this becomes y plus 12 equals -2 times x plus 11. At this point, we would distribute the -2 on the right side, so we have y plus 12 equals -2x minus 22. We then move all of our constants to the right, which will be true regardless of the ending form. So we subtract 12 from each side, the 12's cancel on the left, leaving y equals -2x minus 34. But because we want our answer in standard form and not slope-intercept form, we need to move our x's to the left side. So we will add 2x to each side of the equation, and that will leave us with 2x plus y equals -34. Another example. Let's find the equation of the line through -4, 0, and 6, -1. Write the equation in standard form. Again, standard form, x and y are on the left side, constants on the right side. Now, before we can begin and use point-slope form, we need a slope. So let's use the information given, x1, y1, and x2, y2, to find the slope. Hopefully you remember the slope formula. If you don't, it is m equals y2 minus y1 over x2 minus x1. And now we can plug in the information that we just labeled. -1 minus 0 over 6 minus -4. That becomes -1 over 6 plus 4, which is 10. So we now have a slope, -1 over 10. We have a slope, we have an x1, y1, so we can write our point-slope form and fill in the appropriate information. So filling in with m, x1, and y1 will give us y minus 0 equals -1 over 10 times x minus -4. Now remember, adding or subtracting 0 is not helpful at all, so we cancel out the 0. When we subtract a negative, that's like adding a positive, so this becomes y equals -1 over 10 times x plus 4. Now at this point, you may decide you don't want to deal with the fraction, and if that's the case, we will multiply both sides by that fraction's denominator. On the right side, the 10's cancel, but we still have the -1. On the left side, we have 10 times y. So the left side becomes 10y. Now, if we look back at that last line of work, we're going to take this -1 and distribute to both pieces, both terms inside parentheses. -1 times x is -x. -1 times 4 is -4. As we go back to the directions, we were told we want to write the equation in standard form. The only step we need to do now is move x to the left-hand side. So we add x to both sides of the equation. The opposite x's cancel on the right side, and we're left with x plus 10y equals -4. Example where we are given 2 points, but instead of writing it in standard form, we want the result in slope-intercept form. So we want to find the equation of the line passing through the points 2, 5, and -4, 3. Let's start by labeling the points x1, y1, x2, y2. Because we are not given a slope, we must plug this information into the slope formula, which we're going to write. It's always good to write our formulas every time we work a problem so that you have a better opportunity to remember those. We plug in the labeled information. 3 minus 5 is -2. -4 minus 6 is -6. Excuse me, -4 minus 2 is -6. And this will reduce to 1/3. Now that we have a slope, we can plug in the essential information into the point slope form. Y minus y1 equals m times x minus x1. So plugging in m, x1, and y1 will give us y minus 5 equals 1/3 times x minus 2. Again, at this point, you may decide that you don't want to deal with the fraction, so we will multiply both sides by the denominator. Doing so will cancel the 3's on the right-hand side. We will distribute the 3 on the left-hand side. We're left with 3y minus 15 equals, distribute the 1, which really isn't necessary, but we'll do it anyway. On the right-hand side gives us x minus 2. Let's now move all of our constants to the right. We add 15 to both sides. We're left with 3y equals x plus 13. Now we go back to the instructions where we are told to write the equation in slope-intercept form. Slope-intercept form is y equals mx plus b. So we want to get y isolated. And at this point, we're multiplying y by 3. So we divide every term by 3. And that gives us y equals, now x over 3 can be rewritten as 1/3 x. Y equals 1/3 x plus 13 over 3. Finding equations, remember that non-vertical parallel lines have equal slopes. Non-vertical perpendicular lines have slopes that are negative reciprocals. That means flip and change the sign. If you rewrite linear equations into slope-intercept form, we can easily determine the slope to compare lines. So here we are given similar instructions, but with different information. Find an equation of a line that contains the point -2, 4, and is parallel to the line x plus 3y equals 6. Write the equation in standard form. Again, before we can plug into the point slope form, we need to have a point, which we do, x1, y1, but we also need a slope. And here we're not given that additional information explicitly. It doesn't tell us the slope. It doesn't give us a second point to plug into the slope formula. It only gives us a line and the fact that we want to be parallel to that line. Remember, parallel means same slope. So if we can find the slope of x plus 3y equals 6, then we will know the slope of the equation we want to find. Let's see what we can do with x plus 3y equals 6. If we can just put it in slope-intercept form, y equals mx plus b, then we can know the coefficient of x will be the slope. So let's go through the steps necessary in order to do that. First, we would subtract x from both sides. Opposite x's cancel on the left. We're left with 3y equals negative x plus 6. Then we would divide every term by 3. The 3's cancel on the left-hand side, and we're left with y equals negative x over 3 is the same as negative 1/3 x plus 6 divided by 3 is 2. Now once we have y isolated, we compare our equation to the slope-intercept form, and we find that the number, the coefficient in front of x, negative 1/3, is our slope. So the old slope is negative 1/3. Because our slope is going to be parallel, which means exactly the same, the new slope is also going to be negative 1/3. So the information we need that we're going to use is the slope is negative 1/3 and our point is negative 2, 4. Let's go to the next slide and try to use that information. So we had slope was negative 1/3. Our point was negative 2, 4. We're going to plug that information into the point slope form. Y minus y1 equals m times x minus x1. So plugging in gives us y minus 4 equals negative 1/3 x minus negative 2. Change subtraction of a negative into addition of the positive. This becomes y minus 4 equals negative 1/3 times x plus 2. Let's eliminate the fraction from the problem, at least for the time being. I'm multiplying both sides by the denominator of the fraction. On the right side, 3's cancel. So on the left side, we distribute the 3, which gives us 3y minus 12 equals, on the left side, we want to distribute the number that remains, the numerator. So distribute the negative 1. Whenever you have a negative slope, keep the negative sign with the numerator. Don't try to multiply the negative through to both sides of the equation. Negative 1 times x is negative x. Negative 1 times 2 is minus 2. We now move all of our constants to the right side. So we're going to add 12 to both sides of the equation. We're left with 3y equals negative x plus 10. Now, if you remember the directions from the last slide, we were told to find the equation in standard form. So we want x and y both on the left side of the equation. We add x to both sides. The x's cancel on the right side. We are left with x plus 3y equals 10. Another example where we're not explicitly given the slope, we want to find an equation of a line that contains the point 3, negative 5. We can label that x1, y1, and is perpendicular to the line 3x plus 2y equals 7. So we're going to use this information, perpendicular to this particular line, to find the slope. Once we have our information, we will write the equation in standard form, meaning x and y on the left side, constants on the right side. So because we don't have a slope, we start by taking the old equation, the reference equation, and solving for y. We start by subtracting 3x from both sides. 3x's cancel on the left, and we have 2y equals negative 3x plus 7. Let's divide every term by 2. 2's cancel on the left side, and we have y equals negative 3/2 x plus 7/2. Now, when we compare our equation to the slope-intercept form, we see that the coefficient of x, negative 3/2, takes the place of m. And here, m is going to represent the slope. So the old m, the old slope, is negative 3/2. But remember, our slope needs to be perpendicular to this. And to find a perpendicular slope, we have to flip and change the sign. So if we do that, our new m, the slope that we're actually going to use, If we flip negative 3 over 2, it becomes 2 over 3. And instead of a negative, we will have a positive slope. So our slope is 2 over 3. Our x1, y1 is 3, negative 5. Let's go to the next slide and use that information. So m equals 2 over 3. Our point was 3, negative 5. We're going to use this information in the point slope form. So plugging in for m, x1, and y1 gives us y minus negative 5 equals 2/3 times x minus 3. So we start by changing any subtraction of negatives to addition of the positives. So we have y plus 5 equals 2/3 x minus 3. Let's now multiply both sides by the denominator of the slope. So the 3 that we're multiplying by and the denominator cancel. We'll be left to distribute the 3 on the left-hand side. 3y plus 15 equals. On the right-hand side, we will multiply the numerator that's left to both terms inside parentheses. 2x minus 6. Now, regardless of the form we want, we always start by moving our constants to the right-hand side. That gives us 3y equals 2x minus 21. Because we want our answer in standard form, we now move our x terms to the left-hand side. We subtract 2x from each side of the equation. The 2x is canceled on the right. We're left with negative 2x plus 3y equals negative 21. Example, write the equation of the line passing through the given points. Write the equation in standard form, and here the generic standard form is given, ax plus by equals c. Now for this problem, we have 2 points. We can label them x1, y1, x2, y2. And because no information is given for the slope, we have to use these 2 points in order to find the slope. So we start with our slope formula. M equals y2 minus y1 over x2 minus x1. Plugging in the labeled information, we have 9/5 minus 3/5, all divided by negative 1/5 minus 8/3. So in the numerator, we can go ahead and subtract. 9 minus 3 is 6, so this becomes 6/5. In the denominator, we must first find a common denominator between these 2 fractions. So the common denominator of 5 and 3 is 15. We multiply the first fraction by 3 over 3. Remember, whatever we do to the top, we do to the bottom as well. The 8 over 3 we multiply by 5 over 5. This will give us negative 3 over 15 minus 40 over 15. So at this point, we have the slope equals 6 over 5, all divided by negative 43 over 15. Remember, when we have a fraction over a fraction, that's the same thing as taking the fraction in the numerator and dividing by the fraction in the denominator. When we divide fractions, we're actually multiplying by the reciprocal. Now at this point, we try to simplify somewhat. 5 divides 5 once, 5 divides 15 3 times. 43 is prime, so 43 and 6 and 43 and 3 have no common factors. We multiply what's left. 6 times negative 3 is negative 18 over 1 times 43 is 43. So our slope, albeit horrible, is negative 18 over 43. We're going to use the slope and x1, y1 on the next slide, plug in, and try to find an equation in standard form. So the slope is negative 18 over 43. our x1, y1 was 8/3, 3/5. So we use this information and we plug into the point slope form. So plugging in for m, x1, and y1, we have y minus 3/5 equals negative 18 over 43 times x minus 8/3. So we start off with three fractions. What we want to do first is just eliminate the fraction associated with the slope. So let's multiply both sides by the slope's denominator. The 43's on the right side cancel. On the left side, we have to distribute 43 to both terms inside parentheses. So when we do that, we get 43y minus, now remember, when we multiply a whole number times a fraction, that whole number is really over 1. So think of this as 43 over 1, at least in the case where we're multiplying the fraction. And when we do so, that will become minus 129 over 5. On the other side of the equation, we take negative 18, the numerator that remains from the slope, and multiply both terms on the inside of parentheses. So we're left with negative 18x. Now, because we have a negative and a negative, that will become a positive product. Again, that negative 18 times negative 3, we only multiply the tops because we can think of this as negative 18 over 1 when we're multiplying the fraction. So only multiply your whole number by the numerator. And when we do so, we take 18 times 8, and that will give us 144 over 3. Now this is something we can actually reduce. 144 over 3 will reduce to 48. So let's write everything else exactly the same and decide what we should do next. Now remember, regardless of our final form, we always move our constants to the right-hand side. So we add 129 over 5 to both sides of the equation. When we do, the 129 over 5 cancels on the left-hand side. We're left with 43y equals negative 18x. Now we have to try to add these whole numbers and fractions together. So we rewrite 48 over 1. To get a common denominator, we multiply 48 over 1 times 5 over 5. So we multiply 5 on top, 5 on bottom, and that gives us, let's just do this off to the side up top. Sometimes we have to do scratch work so that we can plug the nice or somewhat nice numbers back into the problem. So this becomes 240 over 5 plus 129 over 5, which is 369 over 5. So what we have is 43y equals negative 18x plus 369 over 5. At this point, because we want our answer in standard form, we add 18x to both sides. So we cross out the 18x and negative 18x on the right-hand side, and we're left with 18x plus 43y equals 369 over 5. Here are some helpful hints that you may not remember, but are necessary for a few problems, just like they were in Module 4. Vertical